bigger experiment. It's a dissection of the brain out of the mouse's skull. There are different ways you can achieve it, and a common strategy is to cut the fur along this line and to sever the connection to the spine. You then insert forceps into this hole at the back of the skull and remove the skull on top by just lifting it upwards. The brain is then exposed and can be lifted out of the skull. And usually the brain is post-fixed in the same fixative that is used in the perfusion. Since most of you, or not, or all of you probably, have never seen a mouse brain, I'd like to give you some information about its orientation and some terminology that you will need later today in an exercise. This is a top-down view. The olfactory bulbs are located in the front, we call it rostral, and the cerebellum is located at the back, we call it caudal. In the middle, this is a side view, again rostral and caudal, and the ventral is at the base of the brain and dorsal kind of at the top of the brain. The terms medial and lateral we use in relation to the midline. So about these two dots here, you could say, for example, that the red dot is located more medial compared to the yellow one. You just interrupt me if you have any questions, by the way. Okay, so now that we have isolated the brain, we would like to process it. Very often, we would like to use it for immunostainings, but we cannot do this on an entire brain. Why is that? So as you heard yesterday, immunostainings are based on antibodies recognizing certain proteins. Antibodies are quite large molecules and cannot easily diffuse into the tissue. And we therefore have to section the brain into very thin slices of about 25 micrometers. And to section the brain, we use a machine called vibratome. As the name already indicates, the blade of a vibratome is vibrating. With those buttons here on the left, we can regulate the frequency of this vibration, the cutting speed, and we can set the thickness of the section that we desire. The brain is glued to a stage, and the stage is mounted into a bassin filled with PBS. When you start the machine, the blade moves forward, cuts the section will start floating on the PBS, and you can pick it up using a paintbrush. So here is a short video where you see this more detailed. So it is cutting. The section is so thin you hardly see it, but now you can see a little bit, and the paintbrush is coming and you pick it up. So now I have a small riddle for you. These two Petri dishes contain brain sections of two brains, both brains of the same mouse strain, the same gender and same age. But why do they look so different? And I would like some of you, to just shout out their ideas. What is different here?
It's a different cutting direction.
Exactly. The brains are cut in different body planes. We have three so-called body planes. One is horizontal in green, the coronal plane in blue, and the sagittal plane here in red. When we cut our brains, we have to decide which type of cut will be most informative for us. Since the blade of a vibratome is always horizontal, therefore, dependent on what type of section we need, we glue the brain in different orientation to the stage of the vibratome. For example, if you would like to have a coronal cut, you glue the brain with the cerebellum pointing down. So at this stage, we have our sections and they're already ready to stain. And after the staining, you mount the sections on top of glass slides in preparation for microscopy. For the mounting process, you would put a small drop of PBS onto your glass slide, then carefully transfer the section onto the drop and unfold it using your paintbrush. Then when you have your sections nicely unfolded, like on this slide here, You can use mounting medium to embed the sample for imaging and cover the sections using a cover glass. So much to sample preparation. I hope that was all clear. And now we would really like to move on to the practical part, in which you will learn to discover, like you yourself will discover the functional areas of a mouse brain. This slide shows you the images of an unstained section on the left. And this section here is stained for nuclei, and that one here shows you a myelin staining. And you can already appreciate or see by eye that the brain is not homogeneous, but that it is structured. And structure is usually an indication for function. So you will explore brain anatomy and the function of different brain areas using the Allen Brain Reference Atlas. So you have the link on your slides, the atlas. I just show you how it looks like. So when you open the atlas, you can already choose between an atlas of coronal sections and an atlas of sagittal sections. For this example, I opened the coronal atlas. And this is how it looks like. In the main field, you have an interactive atlas with different functional brain areas in different colors. In the window to the left, you find a list of all structures sorted hierarchically. If you click on this area here, for example, you can read in the upper left corner that this nucleus is called posterior hypothalamic nucleus. And in the hierarchy list, you can see that this nucleus belongs to the hypothalamus and that the hypothalamus belongs to the brainstem. Then down here, you can slide and move to sections more rostral or sections more caudal. In this drop-down menu here, you can change the atlas. Today, we will only use P56. P56 means postnatal day 56, so an adult mouse. So P56 coronal and P56 sagittal atlas of a mouse brain. And the sagittal atlas works exactly the same way. And really what you have noticed by now, and this helps enormously, the atlas is color-coded. For example, cortical areas here are colored in dark green. The hippocampus is shown in light green and the cerebellum in yellow. But now it is really your turn to get to know the mouse brain. So you will open the Allen Brain Atlas and then try to answer or solve this exercise. I will not read them to you. You can do this yourself. I think it's really explicit what you have to do. You have 1 hour for this whole exercise. At 10:50, we would like you to check in with your tutors. Then we will make sure that you have understand the assignment. And at 11:30, we will discuss your results with your tutors. So the tutors of today are Lisa, Elike, me, Lina, Dietmar, and Charlotte. And if anyone forgot in which group he or she is, we have them written here. So are there any questions right now?
The first exercise.
Yes.
So sketch the brain section on slide 25.
Yeah, this is this one.
Okay.
This is slide 25. Okay, so if there are no further questions, I would say let's get started. And don't forget to check in with your tutors at, what did you say, 10:50. Good luck.